In the first two sections of chapter 7 here, we are going to talk about solving oblique triangles. Now, oblique just means not a right triangle. All right, so there are 4 cases that we're going to look at. Now, in this lecture, we're only going to look at the first case. All right, so the 4 possible cases are: we know 2 angles and 1 side of the triangle, and we can then find the other angle and the other 2 sides. The second case is if we know 2 sides and an angle that's not in between those 2 sides. The third case, 2 sides and the angle that is in between them. And the final case, all 3 sides are known. Okay, so what we're actually going to use for these first 2 cases, we're going to use what's called the law of sines. And then for these other 2 cases, we are going to use the law of cosines. Now, for these second 2, we will actually end up using the law of sines at some points as well, but we will have to use the law of cosines to start. Now, today we're just going to start by talking about the law of sines. So we're only going to look at case 1 in this lecture, where I know 2 angles and a side. All right. Now, before we start, let's just talk about general notation real quick. So in a triangle, generally we label the angles using capital A, B, and C. Then the sides opposite those angles, we use lowercase letters. So the side that's opposite angle A would be lowercase a. The side that's opposite angle B will be lowercase b, and the side opposite angle C will be lowercase c. Okay, so this is just general notation that we're going to use for triangles. All right, the angles are capital A, B, and C. The sides are lowercase a, b, and c, and the lowercase a is opposite angle A, and so on. All right, so let's first derive the law of sines. Okay, so let's take some triangle ABC, where the opposite sides are lowercase a, b, and c, and let's draw some altitude in. Okay, and altitude is just another name for a height, where I just draw a line straight down from C to create a right angle with the opposite side. So let's talk about angle A here. So if I want the sine of angle A, well, that's going to be equal to the opposite side over the hypotenuse, because we're talking about this right triangle right here. Okay? By dropping a height, we create right triangles. So the sine of angle A is going to be opposite over hypotenuse. So that's h over b. Now, similarly, over here, if we talk about the sine of angle B, we can say that's going to be, again, now looking at this right triangle right here, that's going to be opposite over hypotenuse, h over a. Now, if I take each of these equations and solve them for h, I would just multiply b here. We would get b times the sine of a is equal to h. And then here, multiply the a over, we get a times the sine of b is equal to h. Well, now, since these 2 expressions on the left side are both equal to h, I can say they're equal to each other. So I can actually now say b times the sine of a is equal to a times the sine of b. And this is a form of the law of sines. Now, more generally, we'll see it written like this. If I divide this b, the lowercase b, over to the right side, and I divide this A over to the left side, we'll end up with this. Sine of angle A over side A equals sine of angle B over side B. Okay? Now, we can actually do the same thing for something like this. If angle B is obtuse, okay, we could actually set up the exact same thing. I'm not going to go through that proof, but just understand that it doesn't matter if angle B is acute or obtuse. We could do this exact same derivation to get the law of sines. Now, we could actually also do the same thing for angles A and C, or angles B and C. So what that ends up meaning is we get something like this. Okay, if I do that same proof for angles B and C, we could say this: sine of B over side B equals sine of C over side C. And for angles A and C, we would get this. Now, we can then combine those into a single equation to relate all the sides and all the angles in any triangle to look like this. Okay, so this is the law of sines. Now, we could also obviously just take the reciprocals of all those and write it like this. Okay, but usually we'll see it written like this: sine of angle A over side A equals sine of angle B over side B equals sine of angle C over side C. And we can use this to solve triangles, solve for missing pieces in triangles. So let's go through an example. All right, so in this problem, it says solve triangle ABC, where we know angle A is 62 degrees, side C is 14 feet, and angle B is 74 degrees. So let's start by drawing a picture. Okay, draw a triangle. It doesn't really matter what the triangle looks like. All right, but let's draw a triangle. Put it over here a little bit, and then label our pieces. So let's say we've got angle A, angle B, and angle C, and then this is side A, side B, and side C. So the information that we already know is that angle A is 62 degrees, angle B is 74 degrees, and side C is 14 feet. Now, when it says solve the triangle, that means find all the other missing pieces. Okay, so let's first look at what we have. Okay, in this triangle, I have two angles and the side that is in between them. Okay, that means that this is an angle side angle case. Okay, two angles and the side in between them. So if we think back to that first slide, that's part of case one, right? I know two angles and a side in between them, okay? So we're just focusing on case one here. So what we want to do first, if I know two angles, I can very easily solve for the third angle because I know that all three angles in any triangle add to 180. So I can say first that the measure of angle C is going to equal 180 minus the other two, minus 74 minus 62, and that will get me 44. So angle C here is 44 degrees, and we already have one part done. Now, when we're organizing our answers, okay, what we want to do is right by our picture, we want to write these out. So even the given parts. So I'm going to write out angle A, angle B, and angle C. So we already know all three of those. I know angle A, 62 degrees, angle B, 74 degrees, and angle C we just found to be 44 degrees. Now, then we also want to write our three sides. So side A, we don't know. Side B, we don't know. Side C, we already know is 14 feet. Okay, so now let's use the law of sines to find A and B. So we're just going to use part of the law of sines, right? We're going to set up a proportion. Okay, so I already know one side and its opposite angle. So I could set this up as the sine of, I'll write it out first. I'll write the sine of C over side C is equal to, now let's solve for A first. So we'll do the sine of A over side A. So now I know three of these pieces, right? I know that C is 44 degrees. So we'll say sine of 44 over 14 equals sine of 62 over A. All right. So now I'm going to solve for A. So to do that, I'm going to multiply this A over here. All right. So come down here a little bit. So if I multiply this A over here, we'll have A times sine of 44 over 14 equals sine of 62. And now to get A by itself, I'm going to multiply both sides by the reciprocal here. So I'm going to multiply both sides by 14 over sine of 44. And what we'll end up with is A equals 14 times the sine of 62 all over the sine of 44. Okay, so I just took this sine of 62 and multiplied it by 14 over the sine of 44. All right, so now we can put this into the calculator to get angle A, or I'm sorry, side A. So let's go to our calculator, and we need to make sure we're in degree mode. Right? So go to mode, make sure we're in degree mode. Then we're doing 14 times, what was it? Sine of 62 over sine of 44. So 14 times sine of 62 divided by sine of 44. And we get that side A is 17.794. Now, I believe in most of the directions we're going to be told to round to the nearest tenth, so that would be 17.8. Right. So we can fill in side A is 17.8 feet. And now we just want to set up something similar for B. Okay, I can use this same first part over here, so I can say sine of C over side C equals sine of B over side B. Then we've got sine of 44 over 14 equals sine of 74 over B. And then we're going to solve the same way we did over here. So we'll multiply the B over. B times the sine of 44 over 14 equals sine of 74. And then to get b by itself, we will multiply both sides by the reciprocal of this fraction. So when we do that, we'll end up with b equals 14 times the sine of 74 over the sine of 44. And again, we'll just type that in the calculator. So I can actually, since this is almost the same thing, I can do second entry and just go over and change this to 74. And we get that side B, if we round this to the nearest tenth, is 19.4. And we have solved the triangle. Right now, one real quick way to make sure that the answers make sense, if you remember back to geometry, the longest side should be opposite the largest angle. So angle B is the largest angle here, it's 74 degrees. That means the longest side should be opposite that, and it is. Also, then, the smallest angle should be opposite the shortest side, and that is also true. All right. Now, one real quick thing, if you're at home and don't have your own graphing calculator, there is a calculator app, totally free, on both Android and iPhone, that is called Graphing Calculator X84. So if you search for that on Google Play or on the App Store, it's totally free, works on both platforms, and it looks pretty similar. It's not identical, but it's pretty similar to the graphing calculators that we use in class. Okay, so this is a good free app if you don't have access to a calculator at home. Okay, so I'm going to ask you to try a few of these problems. All right, so just send me pictures of your work when you get them done. All right, and send me any questions that you have.